Hi everyone, in this video I'm going to show you how to use PHStat to compute confidence intervals and do sample size calculation. So once you've installed PHStat with the link given in the announcements, you'll double click on it to open it and it will ask you if you should enable macros. You need to enable macros because the way these statistics work in PHStat is there's a few macros written in the background which need to run, which perform the computations that you need. So once you have it installed, you go to Add-ins, PHStat, and since we've been working on confidence intervals in Chapter 8, we're going to do an estimate for the mean with sigma being known. So we choose sigma is known. So as we learned previously, this is going to use a z-statistic. So now we need to enter a population standard deviation. So I'm going to make up a number 0.02, a 95% confidence level. We're going to say the sample statistics are known, which means I know the sample size and the mean. If I didn't and I had the data in a spreadsheet, I would choose this option, sample statistics unknown, and then I would use this here to highlight where my data is sitting. Or here, the sample statistics, we're going to pretend that they're known. So let's say we have a sample size of 100 and the mean is 10.998 as it was in example 8.1 on page 277. So now I've set my sample size, my mean, I know my standard deviation. We want a 95% confidence interval, and now we can hit OK. And you see we have the data that we input here highlighted in turquoise blue. So we know that the standard deviation was 0.02, the sample mean was 10.998. We had a sample size of 100 and we want a 95% confidence interval. So this will give you the z-value or the z-score that corresponds to an alpha of 0.05, which is equivalent to a 95% confidence level. It repeats the standard deviation that we gave it. So now we know that it's going to be the mean plus or minus 0.0039. This gives us a confidence interval of 10.99 to 11. Here we're going to do another example using PHStat, and we're going to pretend we have a small data set with 4 data points and the population standard deviation is known again. So we're going to go to our add-ins. Once we have the data, confidence intervals, we want an estimate for the mean, sigma is known. So now we need to tell it what the population standard deviation is. We're going to say it's 0.2 this time. And this time the sample statistics are not known. So I have to pick where my data is. I don't have a label in the first cell. So I'm going to uncheck this button. And now I'm going to highlight my 4 data points. I can give my chart a title, example, and now I'm going to hit OK, and you can see here in the turquoise box at the top I have the information that was given. So it computed the sample mean from those 4 data points, and it's telling me that the mean was 5 and I have a sample size of 4, which is correct. I've chosen a confidence level of 95%, which is going to give me a z-score of 1.96. So here I have my 95% confidence interval being 4.8 to 5.2. Next, let's do an example where the population standard deviation sigma is unknown. So let's say that I have the sample statistics. I'm actually going to make them up for you. So here we're going to use estimate for the mean, sigma is unknown. So here it looks slightly different, but it's the same idea. I need to pick a sample size. So let's say I have 100. Let's say my mean is 50 and my sample standard deviation is going to be 3 this time. I can give it a title. Then I hit OK, and it's going to repeat here that the standard deviation was 3. That's what I set it as. I have a sample mean of 50, a sample size of 100, I picked a 95% confidence interval. So this time it automatically knew to use the t-statistic, and this time it's 1.9842, which is pretty close to what the z-score would have been because I have a rather large sample size of 100. This gives me a confidence interval of 49.40 to 50.60. The other option that we learned about in the lecture was the confidence interval estimate for the proportion. In this case, we need to go to confidence intervals and we want an estimate for the proportion. So here, let's say we have a sample size of 100. Out of 100 tries, 58 were successes. I've changed the confidence level to 99 and given it the title proportions. I'm going to hit OK. And here we have the information repeated back to us in the turquoise. The intermediate calculations are here in the white box, giving us a z-score of 2.5758. So our confidence interval is going to be 0.4529 to 0.7071. Next, we're going to be using PHStat to determine sample size. So let's do a sample size determination for the mean. We're going to go to Add-ins, PHStat, sample size, and then we're going to choose determination for the mean. Let's pick a population standard deviation, 25. We need a sampling error, which we've been calling E in the lectures. We'll pick that to be 5. We require a 95% confidence level, which gives us an alpha of 0.05. We'll give it a title and hit OK. So now we need a sample size of 97 in order to obtain a 95% confidence level with a population standard deviation of 25 and a sampling error of 5. See, it found the z-score for you, which was 1.96, positive or negative, and the calculated sample size was actually 96.0365. We said that we always round up regardless of how small the points are after the decimal, so we're rounding up to 97, so the result in yellow is a sample size of 97. Next, let's find a sample size determination for the proportion. So again, we're going to go to PHStat sample size and do a determination for the proportion. Here we need an estimate of the true proportion, let's say 0.15, a sampling error of 0.07. We'll change the confidence level and say that we need to be 99% confident, and I'll give it a title, proportion. We'll hit OK, and you can see here that we need a sample size of 173. The true calculated sample size was 172.6427, which rounds up to 173. As the confidence level goes up, you're going to need a larger sample size to achieve this. So if I redid this with the same parameters, but now I require a 90% confidence level, you can see that the sample size needed has decreased to 71.